Okay, so moving on. A few things about stats. Mean, median, and mode. All right, as I mentioned, I think most of us know mean, median, mode. Let's quick review. Mean is the average, median is the one in the middle, and mode is the most frequently occurring. Okay? Now, that said, there is some problems with using mean, median, and mode. And quite frankly, there's, in research, in psychological research, I cannot think of specific reasons why you would want to know what the middle number is. Most frequent, yes, you might not want to know that. But a lot of times they try to use the mean. The only problem with using the mean is that means can be biased by an extreme score, okay? As evidence that you probably know by grades, okay? Grades, when you go and, for example, you take a test or a quiz and your teacher's going to pass it back and you're like, oh, well, how did everybody do? Okay? And the teacher says, oh, on average, people got an 80. Right? That's pretty good. Problem is that it can be affected by extreme scores. You could have two people in there that knocked it out of the park and got 100% or 102% or whatever, and it skews everything else of anybody that did really, really badly. Okay? So you have to be really careful with using the mean. You have to know what the range scores are. So I gave this example. I kind of like this cartoon. This cartoon on the top, it says, Mr. Stingy, I have heard that you pay your employees very poorly. Mr. Stingy says, that is an evil lie. The average salary in my company is $91,000 per year. Okay, Mr. Stingy, not bad for a mean salary. But what is the median salary in your company? Okay, the median salary is $80,000 per year. Your accusations are unreliable. I can't believe it. Says, sounds good, Mr. Stingy, but the mode, Mr. Stingy, what is the mode? And then the last square, okay, it shows you the salaries in Mr. Stingy's little company. Mr. Stingy himself makes $300,000. His wife makes $120,000. The accountant makes $80,000. A secretary makes $80,000. I can't believe the secretary makes $80,000. And then you have 3 clerks that make $20,000. Okay? The reason I show this is because it gives a perfect example of why the mean can be extraordinarily skewed. He's like, hey, the average is $90,000. Well, most people actually make below the average. Okay? So, and you have to understand that when you look at headlines in the news. Okay? And sometimes they will talk about the most people in the United States make below the average income. Well, what does that mean? Well, that means that when you actually calculate the average, like, for example, Mr. Stingy's company, okay, you have a bunch of people like Bill Gates out there that make an exorbitant amount of money, and they throw off mean for everybody else. Most people make below that. Okay? So I wanted to give you that cautionary tale there when we were using the mean. All right, measures of variance, on the other hand, are a little more reliable. You do need to know the variation of the data to know the reliability of the data. Okay, so in other words, you need to know the range. In Mr. Stingy's case, going from 20,000 to 300,000, that's a huge range. And there's only 1, 2, 3, 4, 5, 6, 7 people working at his company. Okay? Range makes a difference. Oops. All right, standard deviation, however, shows how packed together scores are because it uses information from each score. So standard deviation, you're looking at basically taking each score and you are taking the absolute value of that score from the mean score. And so you're basically measuring how far away from the average it is. And I won't get into the specifics of how you calculate standard deviation. Might make your head hurt. Okay, so standard deviations oftentimes look like a bell curve. Have you heard of bell curves? Probably. Standard deviation, bell curves, these are the ones that usually they advocate for teachers and educators. They say that this is kind of what you want your grades to look like for your students. You do not want to have everybody at the top end with an A or a B or whatever, but you don't want to have everybody at the end, bottom end either with a D or an F. Okay? Most people should fall into what grade category with this theory? C. Isn't that wonderful to know? You all love C, right? Crickets, crickets, crickets. No, I really don't want to see. Okay. But that's the theory behind it is that it should basically look like this. Okay, depending upon the height as far as how many people you have in your group, but you have your tail ends on the end, or yes, you have a few A's, yes, you have a few F's, most people are in the middle. That's the idea behind it. Okay, last slide. Making inferences. Okay, now that you have all your lovely stats, okay, what do you do with them? Inferential statistics is a lovely branch of statistics about how you actually use the numbers. And I am not a statistician. I will tell you right now, never had a stats class in my life. Okay? But what I will tell you is that you need to be careful when you are reading news items or articles on the internet and they use stats, because they can use stats to their advantage, okay, the way they state things. Okay, so when are results reliable? How do you know when your results of your experiment are actually reliable? First thing is, you have to have a good sample. I talked about this yesterday, is that your sample has to be representative of your population. So it must be random, or I guess it could be a stratified sample, but it needs to be a good sample of the population. Should be reflecting who you are actually studying. The results should also be fairly consistent. You don't want an experiment that's done that you have this wide, huge range of scores and results, because that tells you that they were not consistent across the board. It tells you that it's not just something that you can apply to a large group of people. You want something that has a very small range. Okay, that would tell you that yes, this is something that's fairly consistent, that tells you that, okay, I could potentially apply this to the rest of the population. And you also want lots of cases. Okay, that kind of goes with the whole sampling thing. You cannot just prove your hypothesis based off from 10 people. You can't apply that to the population at large. And remember, the population is whatever you define it as. All right, so then when are differences significant? When is it significant if you have a difference within your particular experiment? So when samples are reliable, then differences are reliable as well. Okay, think about this. When samples are reliable, so in other words, you have a sample that represents your population, okay, and it has small differences, and it was a lot of cases, then any differences within that experiment are also reliable. Okay, so you got to think and process it a little bit, because the way you read the sentence like, okay, but no, think about it. Okay, that means that differences are reliable. So even though you have a small range of differences, whatever differences there are within maybe age or gender or socioeconomic status or ethnicity, those differences are going to be reliable as well if your sample is reliable. Okay, statistical significance then is the likelihood that results happen by chance. Okay, so what are the chances are, what are the, what does it look like as far as that this could just happen willy-nilly out the blue and it's just a fluke accident, okay? Or, what's the statistical significance that your results would happen no matter who conducted the experiment? Are they actually significant results? All right, so, and I should have moved this a little bit. This is a graph kind of showing the differences in a bar graph. And this one is looking at, can't remember, this one is looking at symptoms, initial reactions to a particular drug. Okay, and so they have symptoms on the left-hand side, including headache, drowsiness, numbness, lightheadedness, those kinds of things. And then on the bottom, it has the number of subjects. Okay, the reason I'm showing you this graph, though, is that look at the differences, because the red is the placebo, the blue is the actual experimental group, so the red is the control group, the blue is the actual experimental group. So you can kind of look at the differences between the bars, okay, because remember what we said is that they have to have a good sample, the results have to be fairly consistent, and you have to have a lot of cases. Now, the most amount of cases in this particular study was how many? It's based off of this bar graph. 24, okay, because then it doesn't quite go to 25. So there are 24 participants. And depending upon, I don't know exactly what the study was. What?
61.
Okay, 61 out of the subjects. Okay, so yeah, 61 subjects, but it does tell you, it gives you an idea of it gives you an idea of the differences between them. Okay, so notice in some of the symptoms there's very small differences, and in other ones there's very large differences. Okay, again, you want to look at the differences to see if there's very big differences, as well as this is a very good example of an illustration where it makes a difference on the increments on the bottom. Okay, anytime you look at a graphic, always look at the bottom. How do they measure this? Because if it is a very large increments or very small increments, in this case we're going by fives, the number of subjects. Okay, so if you were going by ones, okay, for example, the differences would look a lot bigger than they are now with just fives on the bottom. Do you understand what I'm saying? Kind of, sort of, maybe. Okay, this makes it makes a difference on how you actually construct your bar graph. Okay, anybody have any questions about statistics or experiments? All right, I am done with notes then.